Okay, welcome everybody to today's topic, which will be mastering the Chrome DevTools. This is one of my favorite workshops to make because, I don't know, I guess I just remember how much I suffered when I didn't know about them, or at least not master them. And I don't know, it just brings me back to my days when I was just learning web development and thinking why somebody did not force me to learn them sooner, because once you master them, or at least get a good understanding of them, you just become so much better at problem solving and identifying front-end bugs. It's just an amazing tool set to use. So today's workshop agenda will be something like this. It's only 3 main topics, which are inspecting HTML and CSS with the Elements panel, troubleshooting network and AJAX requests, and then debugging JavaScript with the sources and the console. So, all right, we have 3 main topics. Let's get started. Before that, quick info. What are the Chrome DevTools for those unfamiliar? The Chrome DevTools are basically just a set of web authoring and debugging tools built into Google Chrome. And these are usually used to iterate, debug, and profile your site. But it just means these are tools that the Google Chrome team made for us to help make our job easier when identifying problems with websites and web applications. And we better make good use of them because they're amazing, simply. Topic number 1, inspecting HTML and CSS with the Elements panel. Now, the Elements panel is the simplest part of the Chrome DevTools, and the first panel you'll be greeted with. It's this one on the left. So basically, every time you open the Chrome DevTools, you will be greeted with Elements by default normally. To show you what that would look like, I just have to right-click on my Chrome instance, for example here, and click Inspect. Anywhere on the page, you should see that Inspect option, and that opens the DevTools, as you can see here. And there's the Elements panel. So that's one way of getting into them. And as you can see, basically the Elements panel is all about HTML. So we use the Elements panel to inspect the DOM tree, sometimes refers as Document Object Model, which is basically a hierarchical representation of your HTML, and it makes it easier to navigate. So yeah, that's the Elements panel in a nutshell, and it's fantastic to use. So let me show you just a super quick demo. Here we have an Elements inspector. Now in this scenario, I am going to right click on this as it's requesting to see why this is blue. And notice how wherever we right click and inspect, it actually highlights it on the DOM tree. Or you can just navigate it by clicking on the elements or using your arrow keys. And the cool thing about this is you can actually see the properties that are applied to this element via the Styles and Computed panel. They're very similar, but basically the difference is that Styles shows everything applied by rules, and then Computed shows everything consolidated into only the properties that were changed. And if you click on the drop-down, it tells you what CSS rule modified that. So it's very handy. And something I really like is you can actually, this is an actual link. So that allows you to click on the link and it takes you to where in your CSS file you wrote that rule. So it's super handy. Then also, this is just a minor bonus points. You will sometimes notice this weird user agent style sheet. This is something I did not write. So spoiler alert, this is a default CSS style sheet that is loaded by every browser. All browsers have this. Otherwise, if they didn't, a paragraph would look the same as a header, and a header would look like the same as a link. So browsers have a default user agent style sheet, which is what makes headers larger, hyperlinks blue, and underlined, stuff like that. So, and you can always, if you don't like any of these default CSS styling by the browser, you can always just override it, but it's just what I did here. In this example, notice how this changes colors when you hover and click. I can actually inspect it, and using this element state toggle button, I can actually manually toggle the states like hover, as you can see here, and it applies the selector I'm using for on hover. Or I can actually use that focus one, which is the one that gets triggered when you click on it, and it gets colored orangery. So yeah, it's pretty handy. And then finally, I should look more important, make me have the important class to see what happens. You can actually add classes by just clicking on this button, Element Classes, and it gives you the option to turn classes on and off, as you can see right here, or add a new class, like it's requesting. Important. And there you go. You can see that when I edit the class important, it applied new CSS rules to it. So it's pretty great at just troubleshooting what's going on. And for example, in this scenario where you see your CSS rules not working, your first guess should be taking a look at the DevTools and seeing if the rules is there and if it's getting overridden. If it's not there, then it's pretty obvious you didn't write your selector correctly because it's not being applied. And if you did write your selector correctly, your next guess would be making sure your CSS is being applied. Okay, great. Let's move on. So that's the demo. Let's continue with the tips panel. So here are a couple of nice tips. You can edit HTML nodes by double clicking on them. And that's true. You can actually edit HTML live while just using the DevTools. Let me just show you that really quick. You can also click on this button to inspect anything on the page. Just click this inspect button. I'm going to inspect this. And I can just double click on this and change it to hello. And I just modify the web page. And that's pretty handy as well. You can move HTML nodes by dragging and dropping. That's true as well. You can troubleshoot pseudo classes by toggling element state. We just reviewed that. And you can toggle, add, and remove classes using the elements panel. We also reviewed that. So overall, it's fantastic for troubleshooting HTML related issues. Now, the computed CSS properties panel is also a big favorite of mine, which we just covered, but we're going to go a bit more into detail. And it's basically great for seeing all the CSS selectors and rules being applied to that specific elements. So it's kind of great at just giving you a big picture overview of what properties are being applied to that element. And also a major feature, which is something you should be relying on early on, is the box model visualizer. Remembering the box model wasn't easy for me. Just that I know it might be easy for some of you, but it wasn't easy for me. Remembering margin, border, and padding, and then content. So seeing this graphically just made it so much easier for me to know, why is that element so large? Oh, the box model explains. So if we take a look at that in the demo, let's see this example. I'm popular, everyone wants to change my color. Let's take a peek. And oh, look, he's right. 3 rules are trying to be applied to this element. First, a general rule, changing this to white. Then H3, coloring this to yellow. Then a class saying, haha, I win, coloring this to orange. And then, no, you don't, as an ID that's changing this to red. So, pretty handy. And also, if you switch to the computed panel, it just looks a lot cleaner. Notice how the color is only red. But if I'm interested in seeing why it's red, I can just click here, and it shows all the rules that applied red to it. So it's pretty handy as well. Just giving you a clearer view. Then we can select that I should be center aligned and right below the text above. Okay, so he should be center aligned. We can check and the styles that the reason why this is not center aligned is, notice that huge green block at the left. This is something somebody who doesn't use the DevTools wouldn't have noticed, that there's a huge green block to the left of it. So let's see why there's a green block to the left. Let's click on computed. Oh, look, it's padding. It has 366 pixels of padding. Holy crap. Who's adding that? Let's take a peek. Padding left. Let's expand that. Oh, look, there's a rule in your CSS. In style CSS line 17, setting padding left to 50%. That's this rule. So it should only be a matter of removing that rule. Let me turn it off by just clicking on the text block here. And there you go. Much better. That looks much cleaner. Now, it should say that this also claims that this should be right below the text above. Why isn't this above? Like, it should be close to it. What is taking all this space? So this doesn't have any space, and the header tree doesn't have any space. So if I click on the inspect panel, I can actually see who's taking up that space. Oh, look, there is a hidden element. Let me take a peek. Oh, look, it's an element saying I'm a ghost. And if I click on the computed, I can see that it's definitely there, and it has a huge margin as well. Why can't we see it? Well, the computed panel says the color, which is the font color, is set to white. So that explains exactly why we can't see this. If I just disable this rule, notice how it's now gray. So if we want to get rid of it, I can just right click and delete it, and delete element, and it's gone. There you go. Now, big warning here. These changes do not get saved to your HTML or CSS files. You have to manually transcribe them to your editor, which sounds like kind of a pain, but in my opinion, it's not a huge deal breaker. Why? Because what I like to do when I have a problem, I like to first fix it on the Chrome DevTools because they're just so handy at fixing things, and then progressively just copy over my changes to my editor once I'm done fixing things. And I like to fix things one at a time so I don't forget all the changes I made. But yeah, I think you should already have seen why they're so handy for identifying HTML and CSS related issues. And then some tips when working with CSS. If you think a CSS property might be getting overridden, check the computed CSS view, because that will show you what properties are being overridden. And then use the box model preview as much as possible, because when combined with the inspector tool to identify alignment issues, it can make your life just so much easier. All right, make yourself a favor and just check this often, because it's just fantastic at helping you troubleshoot design related issues. Device emulation options, these are also a must use for developers in the industry. Basically, the DevTools ships with a powerful device emulator, which allows you to see what the site would look like on a specific resolution. So I think this is a great example. Wikipedia.com looks very different depending on what device you use. So this is the desktop view. This is the desktop size view. So it's nice, it's very informative, it's clean, but it also has a lot of options because of the large canvas in real estate. Now, if I open my DevTools, and I'm going to click on the device emulator button. It's this one right here. If I click it and I select something like a tablet, like so, and then refresh the page, don't forget this part. You need to refresh the page for the resolution to take place. So I'm going to refresh the page, and you can see that the tablet view is much different. Like, notice how it's cleaner, much cleaner. And because there's not enough room, it moved the submenu to a hamburger menu. So, and if we make this, I don't know, the layout on an iPhone 5, which is tiny, by the way, and refresh the page, and scroll to the top. Notice how the device became even cleaner and more readable on small displays like this one. So that's the device emulator in action. Let's move on to the next section, which is the tips. Use the device emulator to champion mobile first design. And also, don't forget you can add more device emulator options by clicking on the emulator settings button on the three dots on the top right. To show you that, let me just quickly open them again. So just by clicking on these three dots, I can go to options. Where are these? Device type. Wait, no, that didn't work. Maybe it's here. Oh, it's here. It's click on the device, click on edit, and just scroll down to what devices you want to add, or you can add a custom device as long as you know the resolution, device to pixel radio, user agent string, stuff like that. But you can find all of this easily on Google in case these devices do not satisfy your needs. Okay, great. Let's move on. For event listeners. Event listeners are also a fantastic resource, because when you're dealing with event handlers, especially like when you do JavaScript on click or on hover on submit, they might not always work, and you might have no idea why they don't work. And this is where the event listeners tab are increasingly handy. So to show you what I mean, I'm just going to open any project on Thinkful project Hunt. For those unaware, this is a fantastic resource for seeing projects submitted by students. So let's just see the code. Let's see if we can see the project live. I wonder if we can see it. I don't think this one. Oh yeah, let's select the quiz app because we just want a simple application. Let's just do the community favorite. Let's see it live. There you go. See the demo. I'm going to see the demo on a new tab. Here's the demo on a new tab. And I'm going to see how, because when I click on the start quiz, odds are it's going to start the quiz. So to verify that, I'm going to right click on it, inspect it. And I want you to notice something. When I have this inspected, the button, and I select the event listeners tab, I am now seeing what events are hooked up to this button. If I click on the click button, I can see that there is a total of 3 event listeners listening to this button click. For example, if I click on this one, for example, click on the code line, it tells me that here, this student is listening to the start button element on click. And that's super handy because, like, even if you already know it's listening for a click, you might have situations where you're not really sure if your JavaScript is working as expected, or you might have questions like, I wrote my JavaScript, but my click is not working. What I would do in this situation is just make sure it has the event listener registered correctly. Also, make sure that the code actually fires. To show that, I can just add a breakpoint. We'll learn about this very soon. And I click on Start Quiz. Notice how the code stops. That means the code is definitely running. So yeah, that's how you make sure this works just using the events panel. Let's move on to the tip section. So as far as tips, if in doubt, or if one of your JavaScript handlers you aren't sure if they're working correctly, always check the event listener subpanel. It's ultra handy at making sure that everything is working as expected. And then quick recap. So if used correctly, all these newfound knowledge and wisdom should enable you to experiment with quick changes to your live running HTML and CSS, quickly identify and fix any CSS styling related issues, as well as verify your CSS rules are being applied as expected. So I think that wraps up the UI part of this workshop. Let's move into troubleshooting network and AJAX requests. This is particularly useful for the students who moved beyond the first part of the course, which were the fundamentals. This is for students that are on what that would be, I think, Unit 2 of the course, which would be API use. And for those that haven't reached that stage, not to worry, but I'm sure you will use this knowledge very soon, because AJAX troubleshooting is very important to make sure you're doing things correctly. So the network panel is basically your go-to resource to see what network calls were made by your website. So basically, when you open the DevTools network panel, you will see all the calls that were made via the internet by this page. And here you can actually see all the calls that were made by when you visit google.com. So when you visit google.com, it makes all of these network calls over the internet just when it loads the page. And that's, you might think this is crazy, but don't be surprised. Like, a lot of apps make on average anywhere from 30 to sometimes even 100 network calls when they load. And I think you will learn eventually why, because that's just the state of modern web app development. It's just getting so crazy at this point. But yeah, coming back to this, this is just a visual representation of every HTTP request made by the page, and this includes the loading of any kind of resource. But you can use this to troubleshoot AJAX requests or XHR requests. Also, quick, super important note, for this to show a real list of events, you need to open this, click on the record button, this red button you're seeing right here, and then refresh the page. That will enable you to see and record all the network calls. If you just open this after the page was loaded, you will see nothing, okay? So super important. Quick demo, same thing as previous. We open a project from Project Cont. We're going to open this time an API capstone. So let's use the community favorite. Let's see the demo. And this time we're going to monitor the network panel very closely. So far it's only been making requests for JavaScript, fonts, and files. Let's start. And wait for this to load. There we go. So it's still nothing. Let's just select this example, sequence timer. Let's click on. And there we go. Here's an XHR request. So this is what we call an AJAX request. So basically here that's telling us that this student tried to access the following link. So this student used the lighting yoga-API. And here we can see that this is the request that was made. Here are the request parameters. We can see that the request was successful. They got a status code of 200. and even query string parameters nicely formatted like so. And then you can actually see what was the response from the server by clicking on the preview panel, and that gives you a nice, well-formatted list of data. And this is what the server responded with. You can actually navigate this, or you can just click on response and see it in raw, but that's not very easy to navigate. It's just one huge JSON file. And it's formatted that way to save space. So yeah, that's the Ajax panel. It's very handy, right? Let's move on to the next part of the course, which is the tip section. So as far as tips for the network panel, when recording the network event timeline, it's highly recommended you do it in an incognito tab or a Chrome instance without extensions. The reason why we say this is quite simple. You might not know about this, but extensions also sometimes transmit data over the internet, and they can add noise to your request. And for that reason, I recommend you always try to only record network requests in an incognito window or a Chrome profile without extensions. It just helps get cleaner logs, okay? Now, if a request looks like it threw an error, Google the status code. This is status codes explain a lot more than you think, so always Google them. When I was first learning, I didn't understand their importance, but holy crap, just getting, or at least being able to Google them and figure out what they mean tends to help huge to understand why the server threw an error. Odds are you're doing something wrong, and the status code is going to tell you what you did wrong, okay? Great. Let's move on to inspecting network requests. So this is something we already recovered, but let's just quickly go over that quick. And it is that by clicking on a request inside the network panel, you can actually inspect the request contents. This includes things like header, URL, or any kind of data payload you send to the server. And you can also, as usual, inspect the response, which basically just gives you a preview of everything that was responded by the server. Okay, let's just quickly overall see another quick demo. Just to recap this super quickly, let's pick another app this time around. Okay, so this is the My Bookmarks. Let's add a new bookmark with, I don't know, let's do My Bookmark. URL is, I don't know, google.com. And site for Google. Let's rate it 5 stars, submit. And as usual, we can see that we can actually inspect these by clicking on them or close the preview by clicking on the X button. This view, while it might sound simple at first, is actually handy as well, because you can use this to basically see the timing. So you can see the status code at a glance, the type of request, where this request was initialized by. So you can click here and you can see where this request was fired by. And finally, you can see the size of the response, how big it was, the time it took, and then the waterfall is basically just showing you a timeline of how long that request took to get back to you. So, and if you hover on top of it, it becomes even more handy, like telling you things like how long you had to wait for the server to respond and how long you had to wait for the resource to download. This is funny because notice how this request was only 400 bytes in size. And notice how the download only took 3 milliseconds. So the biggest time here we spent was actually waiting for the server to respond. And that is why you sometimes do not want to have too many calls, because usually waiting for the call is what takes the longest if they're small resources. So yeah, that's a network panel in a nutshell. As far as tips, if the response from a server doesn't look very readable and isn't indented or spaced correctly, you can always click the format button on the bottom left, and it has this symbol on it, the curly space symbol. So it's very handy just to format the response in a more readable fashion. And 2 last features, which are network speed emulation. This is a very interesting one, which many of you might not have thought of. Just for your information, you can actually emulate different internet speeds thanks to this setting. So you might be thinking, why would I want to simulate a slower internet connection? And it's funny you ask that. The reasoning is quite simple. There's plenty of statistics to back up that over 50% of worldwide internet browsing and searches going on are done from mobile devices. And there's also strong evidence backing up that a large amount of the worldwide population using mobile internet doesn't have access to 4G internet speeds. So, well, you might think, oh, my web page works and loads all fine and dandy on my ultra lightning fast 4G internet connection. Odds are, if somebody doesn't have a 4G internet connection, your page will load very differently. And this is very common. Like in your computer, you say, there's no problem with the page. It loads in under a second. Well, try slow 3G, because that's the connection speed that a very large amount of the population still has. And most projects you will find out load in a little under 33 seconds, which doesn't sound like a lot, but there is also plenty of evidence backing up that users wait an average of 3 seconds for pages to load. If the page doesn't load within 3 seconds, they just go back and visit a new one. Why? Because why wouldn't they? We live in relatively fast, we're always in a hurry, we're always trying to get to information fast, so they won't wait for your site to load if you're doing poor use of resources. So yeah, definitely try to use more internet emulation options. They're quite important. And finally, this is a bit of a more advanced feature, but I still felt you should know about this, and this is what's called the timeline film strip. The timeline film strip is a feature that allows you to see how your page would look like in slow motion when it's loading. And you might not think this is useful right now, but it will be once you do more advanced web optimization, or want to troubleshoot why a page loads so slowly, stuff like that. So to use this, it's as simple as just refreshing the page, but clicking on this camera icon. This is one you can see right here. So that camera icon will record screenshots as the page is loading, and it's an overall also amazing tool. Just be wary, because this is a very processor intensive feature. Like, it gets even my machine, which is a top of the line gaming laptop, it gets it to slow down. So I wouldn't be surprised if even a Mac also slowed down to a crawl while using this feature. So let's see a demo, and I think this is a fantastic example. So this demo is quite nice, mainly because it showcases how the new Reddit is really nice, but it loads also much slower than the old Reddit. So let's open these two subreddits, as you can see here. So it's just old Reddit versus new Reddit. We're going to turn on screenshot recording. First, we're going to record old Reddit. So there's a record button. We're going to disable cache to do a reload from scratch, and then press Ctrl-Shift-R to do a full reload. And let's see how long it takes to load. Okay, so that is the old Reddit. That took 4 seconds to load basically the DOM content loaded event, or 8 seconds to do the full load. And you can see the screenshots right here. So this is on 2 seconds. This is what the user could see. So basically 2 seconds was the first time the user could actually see something. Then 3 seconds in, they could see a rough skeleton of the app. And then 3 seconds and 47 milliseconds shows basically pretty much 100% functional page. So it was more or less 3 seconds. Now let's take a look at new Reddit. So same as before, disable cache, turn on screenshots, and let's refresh this. So let's wait for it to load. Almost loaded. There we go. So this arguably took quite a longer time. This is now standing at 6-7 milliseconds for the DOM content loaded event, and a whole 10 seconds for the load event. Now, if we take a look at the screenshots, we can see that it looks like for the most part the page was useful during the first second, but I'm fairly certain this is because I'm using like tons of extensions that do caching. So probably this one is a more reliable source. So this is 3 seconds in. You can see the skeleton of the app, and 3.78 seconds is the actual app. Now, this might not look so bad, but bear in mind we're doing this on an ultra fast internet connection. So this is 200 megabytes per second download. So if we do, for example, slow 3G, as we can see here, and let's compare this all over again, we're going to get probably very drastically different results. So this is old Reddit on a slow 3G connection, which is what a lot of mobile experience would be actually using, sadly. Okay, so it looks like for the most part, it loaded everything by the 20-second mark, and the app was usable on second 14th. Now let's do the same test for the new Reddit. Same as before, refresh. So it looks like it hasn't fired any events as far as loading. It's still loading. Wow. I have no idea what this is loading, but it's still consuming data. 35 seconds in and it still hasn't finished. Whatever, I think we can stop recording. Either way, the user could definitely see something really quick. I'm really curious if this is due to caching, due to the extensions I'm using right now, or if it's really that speedy, because in my experience, new Reddit tends to be a lot slower. But yeah, basically I think this still showcases the point that you can use the film strip to record screenshots and use device emulation to see different internet speeds. If anything, this just shows me that, wow, the new Reddit just loves to consume the internet. It's loading things forever and it just doesn't look like it's going to be finished anytime soon. But whatever, let's move on. So yeah, as far as tips for this section, same concept applies as with the timeline recording. Don't do as I did. Do it in an incognito or private tab with no extensions enabled that could interfere with the test results. And tip number 2, recording UI loading performance with the film strip can be very processor intensive. So try to do this with nothing but Chrome open if you have a lower end PC. Right now, Thinkful run fine despite me running that screen sharing option in Thinkful, and also that I'm recording the session at the same time. So I had no problems, but yeah, just if you're having problems, close everything else, because yes, it can be quite resource intensive in some occasions. Now, recap time. If used correctly, all of this newfound knowledge and wisdom should have enabled you to figure out when a resource isn't loaded. So for example, you should always take a look at the network panel if you're curious if your CSS file has loaded. And you would be surprised, like a huge number of mistakes from students seeing, I can't see my CSS changes being applied to my HTML. Did you make sure you're loading your CSS file correctly? Turns out they made a typo and they were loading the wrong file, or they were loading the file incorrectly. But if they had taken a look at the network panel, they would have seen a clear error that their CSS wasn't being loaded because it wasn't found, and that would have told them, okay, so I need to change the URL to my CSS file. Now, also analyze AJAX calls being made and using gathered information to identify bugs as soon as they happen. This is another common problem I see very often with students working on their API capstones. They don't understand, like, I'm making this call to the server API and I don't understand why it works. Well, have you tried taking a look at the network panel? Because odds are you will see by using the network panel if the request was actually made, if it wasn't made, and if it was made, what it responded with. Because depending on those different scenarios, the problem or the solution will be different. Like, if no call was made, then it's as simple as saying you didn't make the AJAX call. If the call was made, but you made a mistake or a problem happened, it means that you didn't make the call correctly. And that's where you would see the response and the error that you got to figure out why you didn't make the call correctly. And if it was made correctly, but you're still not seeing something, it means you made your AJAX request correctly, but you didn't handle the success correctly. So yeah, notice how just seeing the network panel tells you so much about the problem instantly, without having to ask around. And then finally, identify slow websites using network emulation plus film strip recording options. So yeah, that wraps up the network part of the workshop. And we're going to be getting to the final and maybe juiciest part of it, which is debugging JavaScript with the sources and the console. So the console panel is probably your go-to panel, which you should always have open. The reasoning is simple. It has two primary functions: viewing diagnostic and status information about the page. And if Chrome sees something going wrong, it will always notify you via the console. So it won't give you an alert. It won't give you a pop-up. It's just going to print a line on the console. So that is why you should always preferably have it open and keep it monitored. To open the console, we're going to see an example quite simple, but basically the console is just you must have window on the status of the page. And also, a little less known fact, you can run JavaScript in the console. The console is an interactive JavaScript interpreter, and it allows you to run and execute JavaScript in real time. So to see the demo, we're just going to open the new tab page. We're going to open the console by doing either of these two things. So to open the console, let me first turn off recording. There you go. So to open the console, you can just click on the console button right here, and that opens it. Or you can also press the escape key on both Mac and Windows. And if I press escape, it opens the console below, which is my favorite way of having the console open, because I don't know, I just like having it always on site, and it's handy to keep the console open even if you're navigating into another panel. You're always seeing the console. So if, let's say, you try to load a file and it doesn't exist, you're going to see the error here. Like, you'll see it in network panel as well, but you will also see it in the console, making this super handy to help you figure out why things are going wrong. So yeah, and if you try to go open any page like Google, you should usually see some feedback. As far as you can see here, I'm already getting a ton of errors in google.com, unsurprisingly, which is probably because of my ad blocker. So my ad blocker is an extension blocking a ton of requests. So that's probably what's causing all the errors. But that's okay. That's something I'm expecting. But notice how, again, coming back to this, if you're troubleshooting errors, you would probably want to do them in a page with no extensions, because otherwise extensions can add quite a bit of noise to the logs on both the network and the console panel. Okay, let's move on. Pro tips. As far as the console, there are a lot more methods than just console.log. There's also methods like console.info, console.warn, and console.error. The only difference is that they still log information, but they do it in a different way. So for example, if I do console.log 1, it prints it like a 1. For the console.info, normally here you don't see a difference, but in some programs like Node, when you get to the Node part, print the code differently. Console.warn is one of the good ones, because when you do console.warn, it adds a nice warning flag here. So it's kind of handy just to remind you, like, hey, you did something you shouldn't be doing. Maybe I should warn you. And it makes the console really stand out, as you can see here. And finally, we have console.error. That basically, it just prints it out as if it was an error. And it's also very handy, just at helping you identify, like, hey, an error occurred. And it prints it out like an error. So it's also very handy. Then you can also, second tip, to type commands that are multiple lines long, you can also use Shift and Enter. So going back to that example, if I open my JavaScript console, remember how I told you we could type JavaScript? So here's an example. You can also type functions, like so. There you go. And you can also type functions by jumping lines. The difference here is if you press enter, it will basically run this code. But if you press shift enter, it allows you to write multiple lines of JavaScript code inside the console in a properly formatted way. Very handy. And then this one's kind of a new one, which I really enjoyed and actually kind of blew my mind when I found out about this one. You can use $0 to access the currently selected DOM node on the Elements panel. Let me show you what I mean. So I'm going to go to Elements. I'm going to select an element on the page. So for example, here's the input. I'm going to write something. And then while it is selected, I'm going to type $0. And notice how it basically directs me to the element that I have selected. It's pretty amazing, to be honest. I think I can actually use something like text content, maybe value. I wonder if I can access it. I guess not. I guess Google does things differently, but whatever. It's also very handy. And finally, you can use the $_, also a somewhat well-hidden command, to access the value of the last operation. That is wow, when I first learned about it, that also blew my mind. And to show you what I mean, let me run that. So remember how we have our sum function? I'm going to do sum 5, 10 returns 15. But if I do $_ plus 10, notice how $_ evaluated to the previous value I returned. So yeah, that's pretty great for chaining and just playing around with the JavaScript console. It's a pretty handy command to know. And yeah, that wraps up the tips for the console. Now, let's move on to the sources panel. So the sources panel basically allows you to view all the files loaded by the currently loaded website. And these can be HTML, CSS, JavaScript, or even binary assets like images. And it can also be used for debugging JavaScript. So you'll see soon enough how basically you can use the sources panels to inspect every single file that was loaded by the web page, be it a script, JavaScript, CSS, images, whatever, you name it. It's going to be here. And as far as debugging, for those that aren't familiar with debugging at all, debugging is and should be your bread and butter as a JavaScript developer. So if you aren't comfortable with it, that's something we need to fix right now. So debugging is the process by which you identify a code problem, identify and isolate the source, and then either correct the problem or find a way around it. The most common way of doing this task is via interactive debugging, which the Chrome DevTools allows. So the general idea is that you set a breakpoint at some line of code, and this breakpoint is an intentional stopping place in your code. So then your code will stop. Then you can step through your code's execution one line at a time. So while you're stepping through the code, you can actually view and change the values of our currently defined properties of variables, as well as even run JavaScript in the console. And this in turn allows you to identify the exact source of the problem and how to get around it. Remember, when you have JavaScript problems, you should never look at the result. You should look at the source. You need to find the root of it so you can fix it. So the DevTools allow you to do exactly that, to figure out why a problem is going on. And to show you that, I'm going to show you these two errors that are going to teach you about the DevTools. So basically here, we're going to learn about the DevTools in the best way possible by learning to troubleshoot error messages, because this is something I see a lot of students very afraid to do. Like, you see an error and you immediately ask for help, and I don't blame you. This is something I did as well, but I remember the first times my mentor at one of my first jobs came back to me and said, have you tried reading the error? Because like often the answer is literally there. The error tells you what's wrong with your code. So let's figure that out. So in this scenario, if we click on inspect, we can see that there's an error happening saying uncaught error. Whoops, an error occurred. And here we can see a very scary looking message that says at first, at second, at third, at script. And this is what we call a call stack message. The call stack messages are an insanely helpful feature of programming, because they basically tell you, hey, an error happened when I tried to run this line in your code. So script.js, line number 2. The way we read this is file name, 2 dot, line numbers, and in some situations they even give you an extra 2 dots and the column number, which is just wow. It makes my job so much easier. Honestly, I couldn't live without these call stacks. They just make my job so much easier. So you can see that it's telling me that the code crashed on line 2, but also it's telling you what functions run before this that caused this function to be run. And this is where the call stack becomes helpful, because remember, you do not want to be looking at the problem result. You want to be looking at the problem cause. So usually your troubleshooting should begin from the top, and then you should progressively go back into the call stack until you figure out what's wrong. So what we're going to do here is going to click on the errors. We're going to add a breakpoint here, then a breakpoint on line number 6, and a breakpoint on line number 10, and finally a breakpoint on line number 13. Then I'm going to refresh the page, and the difference here is now this is going to stop. Our code now stopped thanks to the breakpoints. So we're going to learn how to debug. So basically, the way you debug is doing the following. when your code is stopped, you can do a few things. So one, more importantly, you can run JavaScript. So remember, we have the console open. We can do stuff like this, which is not very helpful. But we can also do stuff like this. Really handy. Notice how I'm actually calling functions that exist while this is running. And this is where the console just becomes insanely useful. So that's one thing we could do with the console. Number two, you can see the breakpoints you have. You can also see the scope if there are any variables in it. And finally, the call stack, which at the current moment, it's empty because this is the first function that was actually executed. So now I'm going to click on step over next function call, and that takes me to the next line of code. So that is telling me that the next line that was executed was running third. It tried to run the function second. Now, if I try to do step over next function call, it now takes me to what's happening inside of second, which is first. And if I click on step over, it finally takes me to the line that seems to be causing the issue. So the issue here is just, of course, calling this function called whoops, an error occurred, which is what's causing the error to occur. The solution here, of course, would be, well, don't throw an error, kind of self-explanatory, but it was still useful to just guide you on how you would add breakpoints. Also, another little known fact, instead of adding breakpoints like this by clicking on the line number, you can actually write the word debugger like so. Just word of advice, do this in your editor. So it could be either in Sublime, Atom, or VS Code. And basically, when Chrome has the DevTools open and it detects a debugger, it's going to stop automatically. So that's something I do on a daily basis, because otherwise I just have to find the code, which is not always what I want. But yeah, in case you wanted to find the code, it would be as easy as just opening the sources panel, seeing all the files loaded, and just opening the file you want to identify, as you can see right here. So I just had to open the sources, open this fun submenu, and then open the file I was interested in. All right, great. Let's move to this final example. This one's from the official Chrome team, and this one is an exercise they made to help you debug, because this clearly has a problem. Like if we do 5 and 5 and add them together, yeah, that's kind of obviously not 55. So let's figure out why that's returning 55. And this one's a bit more interesting because no error gets triggered. So I have a lot of instances where students have problems and they don't get an error, so they have no idea where to begin. So also notice a question. No worries, we'll get back to this question as soon as we end the session. Get to the questions. Thank you for the patience. Now, going back to this, we can see that an error is happening and we don't really know where to start. So our best guess would probably start with whatever happens when you click on this button. So using our newfound knowledge, we're going to inspect it, go to the event listeners tab, and find who's listening for click events on this. And we can see that this file is listening for click events. Let's click on it, and that takes us straight to the code that's been running. So it's this line. So let's just add a breakpoint on the first line that gets executed by the onClick function to see what's happening. Also, rookie mistake alert, because this is something I see students doing all the time. Do not add the breakpoint here on line 14, because if you add the breakpoint on line 14, not only will it sometimes not be added, but it will stop when the function is being defined. And normally errors do not happen when functions are being created. Like, you want to be waiting or stopping your code when the instructions are actually being executed, when they're being run. Not where they were written, not where they were like... Imagine functions as a paper note of instructions that need to be done. So imagine stopping the person writing the instructions instead of stopping the person actually doing the instructions. You want to be stopping while the instructions are running. So always add the breakpoint on the first line of the function you want to stop. So that should be working. So let's try to add this one more time, but this time with 10 and 10. No, let's 20 to have different values. And there we go. Our code is stopped. Now, this will be a lot more interesting. So we can see that now it's trying to do, if inputs are empty, then do this. Now, let's say we know the inputs aren't empty. So if I do not want to know what happens inside of this function, I can just click on step over. And this is what step over means. It just means go to the next line. So if I click on this, it's going to jump directly to line 19, because that's what will be run like this. When I run this, it's going to be, when I run this, it's basically going to evaluate this. And if you don't believe me, I can just copy this, paste it in the console, run it, and I can see that it's already false. So because this is false, it will not enter this. But if I did want to know what happened inside of this line, that's what these two buttons are for. Step into this current function call and step out of. So if I click step into, now it takes me to the inputs are empty function, because that was what was being executed. And same thing goes. Here, I can also dig deeper by clicking step into, but if I'm not interested in, I can just click on step out of, and step out of just will mean taking me out of this function to my previous execution. And this is where the call stack is handy. The call stack, notice how because we're on a different function, the call stack grew. So you can actually click on it to go back in history between the previous function call and this one. So it's actually pretty amazing as well. Now, let's just exit this function by clicking on step out of. By the way, this is something you would use a lot whenever it might happen to you that you're debugging and accidentally you get inside of jQuery code. And that is not a very fun experience. Like the first time that happened to me, it was a relatively scary experience. Like I had no idea what I was doing. And honestly, I just wanted to close the tab and start over because nothing made sense. So if that ever happens to you, it's as simple as clicking this step out of current function, and that will take you back to whoever called that function. So it's very handy. Now, update label seems like the function that is causing the issue, because notice how it's not 1020 yet. So let's go inside of this function. So click on step into this function. Now, it looks like this is the actual function that is causing the problem. So we can see that addend 1 is equals get number 1, and addend 2 get number 2. So before I run this, something I really like to do is run functions before they're run to see what they output. The reason why I'd like to do this is because sometimes these trigger an error, and it's nice for me to know, like, okay, this is not causing the issue. This works as expected. And this is basically my usual problem solving routine while at work, at my full-time job. I run code, I debug it, and I run it line by line on the console to verify everything works. Because even if you, like, after you solve as many problems as I have, you learn to basically suspect everything. You never know what's going wrong. So you should always assume everything breaks and be cautious about it. So here we can see that this line runs as expected. Let's see if this line runs as expected as well. So, and that runs as well. Now, let's see if the sum works as well. So I'm going to paste it here. Oh, there we have. I think we got our error. So addend 1 plus addend 2 is equals 1020. Now, for those curious, like, why is this happening? That's okay. Like, if you don't know the answer, probably my best resource right now would be, if I didn't know the answer, would be number 1, Google it. Like, Google why this is happening. Google, because, like, there's just so much information out there. There's a 99.9% chance you aren't the first one to have that question. So you will probably find that. But you guys are lucky, because you guys are Thinkful students. So you guys will have a much easier time if you actually find what is causing the problem, thanks to debugging. Basically, all you have to do is send us this log, or even take a screenshot of this and explain to us your problem. And odds are a mentor will get back to you lightning fast. And the reason is quite simple. Like, because you sent us, like, you actually found the root problem of the cause, it's more probable that somebody with more experience than you can take a look at it and instantly know what's wrong. Like, I know the answer already. The answer here is you're trying to sum strings, and strings have very odd behavior when you're concatenating them. So if you want this to be summed as actual numbers, you have to convert them, like so. So you have to do parse int get number 1, like so, to convert it to an actual number. Otherwise, it converts it as a string, and we do not want that. As you can see here, doing that fixed it. And I know that because I'm a mentor, but somebody else could have figured that out instantly, thanks to you figuring out the root cause of the problem. If you do not find the root cause of the problem, let me tell you what happens, because this is something that I learned out the hard way. Because when I was first learning programming, I made a lot of questions that nobody answered, and I just felt bad. I felt like, I think like the programming community is not very friendly because nobody is answering my questions. It turns out I was to blame in some part. It is because I was unaware that most of the people that can help me have full-time jobs, are very busy, because programming is an area where you really have to be passionate about it and just be learning all the time. So people don't really have the time to look at my error, read, or basically if I tell them, hey, I have a problem, odds are they have to download my project, run it, read all of it line by line to see what's going wrong and figure out what's wrong. And most people sadly do not have the time. So basically, yeah, that's the big problem here, that people just don't have the time to troubleshoot your code as much as we want. So if you learn to debug your code and make it easier for people to help you out, you're just going to get so much more answers. Trust me. This is something I learned the hard way. As soon as I started debugging and making questions in a more informative fashion, like, hey, I have a problem, I tried this, I researched this, and I found out this was the root cause of the problem, but I have no idea why that's causing the problem. I just got so many more answers because people were just more easily able to help me out in less time. Not to mention, this is also a bit of a spoiler warning. The programming community is not as friendly as it seems in some situations. And this is something that sooner or later you're going to learn, probably not in a good way. And this is something I had this is something that I faced when I was first learning programming, and it was making questions that people didn't want to ask, or ask me, dude, just Google it. And that's not very helpful. I was kind of angry when I got those kind of responses. But as time went on, I kind of began to understand that these people who sound like very bad people, they might be bad people in a way, but at the same time, I don't blame them, because these people are sometimes tired. There are people that get tired of people like us that are learning, asking the same questions over and over and over again. And this is something that cannot be stopped. Like, we are students. We are all learning. I'm a student as well. I'm always learning new things. Like, I do not know everything. I will always be learning just as you guys are. So there's 100% chance I will ask questions that have already been made dozens of times. However, odds are if you learned your lesson, you're going to do some research before asking a question. And this is what some people tend to have a problem with students that do not do the research before asking a question. And I cannot say I have not seen that at Thinkful as well. That I see a lot of questions in general discussion that could have been solved by a literal Google search of the question they have on Google, and the first result literally answers their question. So please don't take this negatively. I'm trying to sound as friendly as possible, because this is a problem I faced learning programming. Because like you, I was also 100% self-taught. I have no computer science degree. So I faced this problem learning. And I do not want you guys to be a victim of it. Like, met people that know more than you, assuming that you didn't do your homework. People that know more than you, assuming you're being lazy by asking. And I know you aren't. But if you aren't, try to at least put in some time to research it. For those that are doing it already, great. Make sure to include what resources you Googled. Like, for example, because when you see two students asking a question, when you see one, hey guys, I have a problem with my code, and they just link the REPL and just a vague description of it. And then they see another student saying, hey guys, I have a problem with my code. I tried to debug it and nothing worked out, but I did take a look at these two links on the internet and they seem to be similar, but I didn't quite make sense of it. Can somebody explain them to me? Like, you as a mentor already see, like, this person put in a lot more effort into their question. It sounds to me like they worked harder to solve this. So it almost makes you want to make more time to help them. And I know this is unfair, because I know a lot of the students who make vague questions can actually have made a lot of research. And this is I know it's unfair, because it wasn't fair to me. Like, a lot of the times, people assumed I didn't do my homework. People assumed I was being lazy, and I wasn't being lazy. So yeah, I find it very depressing that this part of the community exists, but it's a reality, and a reality I think you guys should be really prepared for and brace yourselves for. So sorry if I kind of went over the time. I left a smaller amount of questions for the end, but yeah, it's just a huge finding of mine, learning how to ask questions correctly, and debugging was just an integral part for learning how to better fit into the programming community model, and overall getting your questions answered more effectively, because I know it sucks when you ask a question and it sits there unanswered for days. That's not a fun experience, and it's demoralizing. Don't get me wrong, it's really demoralizing. So if I can help you guys in any way to help you get questions get answered more frequently or quickly, I'm going to do it. So yeah, I think that covers the last section of the course. Let's just quickly jump to the end, which is the pro tip section. And it's something already covered, which was that adding breakpoints to your code, you can actually type debugger, as we showed before, into a separate line, and the debugger will automatically stop on those lines. And also, this is a fun tip. If you're ever stuck not knowing why your code still doesn't work even after multiple attempts at debugging, Google rubber duck debugging. You're going to have a blast with this. Seriously, like this is like if it ever happened to you where with one of your mentors, you have a problem, and while explaining to your mentor the problem, you figure out the issue. This is rubber duck debugging. So Google it if you're curious. It's a fantastic technique, even used by veteran developers in the industry. Now, thank you everybody for attending. We have about, let's give 5, maybe even 10 minutes if we have a lot of questions. So I hope everybody enjoyed the workshop. As far as the slides, if anybody is interested, I want to give a link to download the slides in PDF format, especially because I have a lot of links. Like if you want to learn more about any of this, just click on the link and it takes you to the official page on the Google Chrome team. And these are super in-depth, super detailed, and this just will give you a master understanding of it. So if you are interested, let me send you a link to the PDF slides. So to do that, I'm just going to give you guys a super quick question feedback form, just rating me from 1 to 10 if you enjoy the workshop. It's super handy for me just to help me improve my workshops. I really try to learn from each one I give. So if you enjoyed it, please let it be reflected on your ratings. If you didn't, please rate me negatively. I want to learn from my mistakes. And after you answer that form, you will be redirected to a page giving you a link where you can download all these helpful slides in case you're interested. So, thank you everybody for attending. As far as questions, does anybody have something they'd like to ask? Could be about anything. Oh, thank you, Josefa. Glad you enjoyed it. Could be about the session. It could be, even if it's not workshop related, seriously. Could be about anything. Comment from Josefa: you run into problems with multiple event listeners on my API capstone. Yes, those could have been super easily solved with this one. Yeah. Fun fact, this is somewhat new. And this is something I didn't know when I was first learning JavaScript. It would have saved my life as well. I suffered quite a bit as well back in the time. It's been 5 years since I learned front-end developer, so quite a long time, I guess. With a lot of suffering, Josefa. That's how I did it. Lots of suffering, learning the hard way, and banging my head against the wall. But if anything, the best advice I've ever received from one of my mentors was, don't forget, success teaches you nothing. Failure is what teaches you. So every time you make a mistake, as long as you learn from it, that's what matters. Now, question from Rachel: do you have to credit the source if you grab code from websites that you like? Normally you don't, but it is nice to credit libraries if you use them. So, for example, create it with, I don't know, X library from X developer, or create it with whatever plugin from X developer. It's not necessary, and you're not considered a bad developer if you don't do it, because there's just so many JavaScript libraries and plugins out there that it's impossible to quote them all. But it's a good practice. Now, I did see a question from Jason Roundtree a while ago. Is he still here? Oh boy, he left already. I guess I'll ping him directly with his answer for his question. Anybody else? I think we have time for one more question. Nobody else? Did you say there was a recording of this? Yes, Usiva, it's actually recording right now. It will be uploaded to YouTube maybe in about 2 hours or so. It takes a while to upload and then process. So yeah, as soon as that's live, I will push it. Always be on the lookout on the general discussion channel. That's where I publish all my recordings. Or you can also just open my YouTube channel. I always upload them there, as well as links to all my recordings. Let me see if I can link the YouTube channel. So here is my YouTube channel. So you can find the recordings right here. There we go. Yeah. All right. Well, I guess no more questions then. Thank you everybody for attending. I hope you enjoyed the session, and I hope I will see you at one of my next workshops. Take care, everybody. Bye-bye.